When a radical equation has two radicals, we start by isolating one of the radicals and squaring both sides to eliminate it, and then if the other radical is still there, we'll isolate the remaining radical and square both sides again. So here we have a radical equation with two radicals. One of them is already isolated, so our first step could be to just go ahead and square both sides. On the right-hand side, the square root of a quantity squared is going to just be 3x minus 5. Those inverse operations cancel each other out, and the radicand just pops out. And on the right-hand side, we're going to use the property that when we square a binomial or square a quantity that has add or subtract in the inside, we have a formula that helps us to do that. We could either FOIL it, but it's better to memorize this formula because this comes up so often. We take the first term, square it, we multiply the two terms together and double it, and the second term and square it. Square the first, twice the product, square the second. So we take this first term and square it, which is 4. We multiply the two terms together to get their product, and then double that to get twice the product. So that's going to be 4 radicals x plus 7. And then we take the second term and square it. So square root x plus 7 squared is just x plus 7. Square the first, twice the product, square the second. Now, we still have a radical that remains, so let's isolate this now by subtracting 4 from both sides. We'll also subtract 7 from both sides, and subtract the x from both sides. So we have 4 times the radical, x plus 7, that remains on the left, and on the right we have 2x minus 16. Now here's where we decide. We can either divide both sides by 4 to completely isolate that radical. 4 divides evenly into 16, but we'll generate a fraction 1/2 as a coefficient on the x, which is fine, but since we're going to be squaring both sides again, I'd actually rather use the property that if I have two things multiplied together inside a parens that's being quantity squared, I can actually distribute that square over multiply. If it were add, I'd have to FOIL, but if it's multiply, I can distribute. And that's useful here because this is multiply in between these two quantities. So if I go ahead and square both sides now, I can distribute that square into both the 4 and the radical, and that will get rid of the radical, which is what we're trying to do in this step. So square the 4, we'll have 16. Square the radical, we have just x plus 7 on the left-hand side. Now on the right-hand side, we again are squaring a quantity with add or subtract on the inside, which means we'll have to use the square the first, twice the product, square the second property, because you cannot distribute a square over subtract, you have to FOIL that. So we square the first term, 2x quantity squared is 4x squared. The product of 2x times negative 16 is negative 32x. Twice that product is going to be negative 64x. And square the second term, negative 16 quantity squared is positive 256. Now let's notice that what we have here is a quadratic equation, and whenever we have a quadratic, the first thing we want to do is set that equal to 0 to then decide which method for solving quadratics we're going to use. So let's distribute the 16 into the parentheses. We have 16x plus 112, and then we'll copy paste the right-hand side so that we're carrying forward a complete equation. We'll then subtract 16x from both sides and subtract 112 from both sides. So we have 0 on the left, 4x squared minus 80x plus 144. Now these numbers are all pretty big, but I will notice that 4 divides evenly into each one of them. So let's divide both sides by 4 to make the numbers smaller. And dividing the left-hand side by 4 is not going to change the fact that we have 0 over there. Dividing the right-hand side by 4, that 4 has to be divided into all of the terms on the right-hand side. And I'm actually also going to switch sides on you too. So we have x squared. 4 goes into negative 80x minus 20x times. 4 goes into 144 36 times, and we still have 0 on the other side. And we'll notice that this quadratic equation does factor into 2 factors of 36 that add to 20 are going to be 18 and 2. Because this is a plus, the signs need to be the same, and this is a minus, they're the same in negative. So it's going to be x minus 18, x minus 2. And then we set each of these factors equal to 0 and solve them individually for x. We'll add 18 to both sides here to get x is equal to 18. We'll add 2 to both sides here to get x is equal to 2. And now we need to take these back to the beginning equation to check our answers. Remember, radical equations sometimes generate extraneous solutions, so we absolutely must check all of our answers every time. So let's start by checking x is equal to 18 back into the original equation. And what that's going to look like is turning each of those x variables into wholes, and we plug our solution 18 into those variable wholes to see if this makes a true statement. 18 plus 7 is 25, so we've got the square root of 25 here. 3 times 18 is 54. 54 minus 5 is 49. And so 2 plus 5 is equal to 7, which is a true statement, and that means that 18 works. And so we'll do this again now, plugging x is equal to 2 back into our original equation. So we get 2 plus square root of 9 here is equal to 6 minus 5 is the square root of 1. So this will be 2 plus 3 is equal to 1. That's not a true statement, and so this solution does not work. The x is equal to 2 quantity turned out to be extraneous. So we only have one solution to this radical equation.